So this chapter is about language, and of course, the first question we want to ask is, what is language? Language is a system uh, that is constructed from multiple different levels of representation to convey meaning. So it's a system with a bunch of different symbolic representations that we use to convey meaning to each other. Each of the different levels of representation uses a set of rules to combine different parts to form different types of representations. The different levels that we have include the form of a sentence or the form of a language, the grammar, and the actual meaning underneath the grammar. Language is used for a lot of different things. Humans use language for pretty much everything. Everything from communicating to each other to communicating with ourselves. Also, we use language to hold and to construct representations of reality. Um, Language is structured from has a certain structure, and most theories of language assume it consists of these domains that are listed here. First, the form of language, namely the different sounds and symbols that we use. The meaning of language, meaning what is the actual meaning or the essence of what you're trying to communicate in a particular sentence, for example. Grammar, which is the rules associated with each language that we have, putting together the different parts of speech to make to build a communication. And then use, how is language used in day-to-day communication? Phonology, semantics, grammar, and pragmatics constitute the main areas. Each one of these levels has different representations of language, different rules that are used to mediate how it works. And language is infinite. I mean, we're able to understand an infinite amount of communication. I mean, just look at poetry and literature. There's just an infinite number of ways to mix and match words, and we're able to understand all of that. So let's talk about language form first. Language form consists of the world of phonology and orthography. Phonemes in phonology are the sound elements. They're the distinct sound units that make up a language. So they're all of the different single sounds that make up language. And so example of phonemes are e, e, o, f, b. Those are all different sounds that we can create with our lips, our teeth, our tongues, our throats, and our chests. All of those work together, and all of those different sounds that we're able to produce have been cataloged as phonemes. Different languages use different sets of phonemes. So, for example, English, American English, and I guess British English too, but American English is a very nasally language. We use a lot of the sounds that we use in English are make use of the nasal cavity. So to a non-English speaker, particularly somebody in Asian countries, we sound very nasally to them. Whereas other languages like German or even Hebrew, those languages use a lot of the guttural sounds from the throat, like stuff like that. They use those types of phonemes. Each language is made up of a different set of phonemes. Um, so a lot, for example, Vietnamese, they have a lot of different phonemes. The wee, wah, wah, wee. They use a lot of those types of phonemes. Um, in in generating their languages, and that's why people that adopt that have learned a language, as kids, and then they learn a second language, they have a particular accent. So for example, if you've ever heard Russians speaking English or French people speaking English, they all have that weird that accent that you can tell where they're from. And that's because they're using their phonemes that they learned when they learned Russian or when they learned French. They're using the phonemes that they have at their disposal in their language to reconstruct the language the second language that they're trying to speak. One of the difficult aspects of studying language is that there is not a one-to-one correspondence between the sounds and the letters that make up a language. We know this in English. There's through and rough, raffle and waffle. You know, um, it's just all these different examples of words in English that are spelled with the same words but are pronounced differently. And the letters that make up a language are what we refer to as orthography, and the sounds that make up a language are what we refer to as phonology. So there's not a one-to-one correspondence between the phonology of a language and the orthography of a language. In some languages, there is a much stronger one-to-one relationship between phonology and orthography. For example, Russian, pretty much the way you write a Russian word in the Cyrillic characters, it's pretty much the way you pronounce it. There's not a lot of weirdness like there is in English. But in other languages, that's definitely not the case. So we go from phonology and orthography to morphology. Morphology is the language is where we bring together the form, the syntax, and the semantics. It's where we bring together all of the parts of language that convey some sort of meaning. Um, Morphological units are the smallest representations that convey meaning and grammatical properties. For example, a single morpheme or morphological unit would be um, like the word cow. It's a single sound, cow, and it conveys a unit of meaning. A cow is an animal. Um, in other examples, words are usually made up of multiple morphemes. For example, cows, that's made up of two morphemes, cow and z, cows. Um, the morphological level is the point where we can bring in syntax and semantics. So it's the point where we bring in the rules for how to put the sounds together. And it's also the point where we bring in meaning, because a morpheme is the smallest sound unit that actually has a meaning. And when we start linking those together, we start creating bigger and bigger words that have more and more meaning. The next level of uh, analysis is syntax. And syntax represents the rules that specify the ordering of words, the order at which words appear in a correct sentence. So, for example, man bites dog versus dog bites man. Those are two completely different sentences. They have the exact same words in them, exact same words, but the order is reversed. And because the order is reversed in the syntax, it gives a completely different meaning. The structure, so the syntactic structure is an abstract representation uh, that basically specifies how words are related by grammatical property. So it's not by meaning, but it's by what those words are. So, for example, nouns and verbs. Nouns and verbs are part of the syntactic structure, as are adjectives, adverbs, prepositions. Those are all the sorts of representations that make up the rules of syntax. Syntax is not just the linear ordering of words. It's not just, going from the beginning of the sentence to the end of the sentence. There's a lot of rules that go into what makes correct syntax versus what makes incorrect syntax. So, in the basic phrase structure for English is illustrated on this slide. So, a sentence designated by the letter S is made up of a noun phrase and a verb phrase. So, Dr. Lopez kissed the kitten. The noun phrase is Dr. Lopez, plus the verb phrase is kissed the kitten. Because I like cats, so I would pick up a little kitty and kiss it if I could see one. That is a complete sentence with a noun phrase and a verb phrase corresponding to the rules of English. A noun phrase is made up of a noun that can be modified by an article like the or an or the, an adjective, and a prepositional phrase. So, for example, we could say fat Dr. Lopez, which would be an adjective, kiss the cute kitten. A prepositional phrase is made up of a preposition followed by a noun phrase. So, in the house, Dr. Lopez kissed the kitten. So, in the house would be the prepositional phrase. So here's an example of syntax versus the underlying meaning. This slide here refers to this slide, A and B, but let me go ahead and just read this to you real quick. So in sentence A, there's 6 constituent nodes or syntactic parts of the sentence. So there's 6 dots basically, 1, 2, 3, 4, 5, 6, and in sentence B, there's 7 dots. But notice that the sentences are identical. Enraged cow injures farmer, enraged cows injures farmer. And in A, there's 6 constituent nodes, and the prepositional phrase modifies the verb phrase. So basically, the result of that is that there's the interpretation of the cow injures with an axe. Okay. In B, there are 7 constituent nodes, and the prepositional phrase is attached to the noun phrase. So this modifies the meaning. So it modifies the meaning to say that the farmer with the axe. So it makes more sense if you look at the sentences, right? So this first one is basically saying, what you're visualizing in the first one is that an enraged cow picked up an axe and injured a farmer, which, of course, cows can't do because they don't have thumbs, so they can't pick up axes and injure farmers. And the way we fix that, of course, is by adding an extra unit in here, an extra noun phrase, so that we can make sure that we throw in a noun phrase to combine with the farmer and axe to make sure that we know that the verb refers to a farmer with a noun phrase. In other words, a farmer with an axe. So the sentence becomes, enraged cow injures a farmer who's holding an axe, instead of an enraged cow picked up an axe and hurt a farmer. So notice the sentence has the exact same surface structure, exact same words, but the syntactic structure can be different based on how you interpret it. William Shakespeare famously wrote, "A rose by any other name is still a rose." In other words, I can take this thing that you know of a rose and I can change its name. I can call it a 2782, right? But that's not going to change your understanding of what a rose is. If I start referring to a rose as a 2782, you're going to pull up this image and smell and feeling of a rose. So the semantics are, that meaning that is conjured up in the mind as a result of interpreting a communication. Some theories don't include separate semantic and conceptual representations. Um, one of the big debates right now is that how are language and concepts related? How are the linguistics of language related to the concepts that we form to understand those linguistics? What's the relationship between those? Some theories don't include separate representations. The semantic representations are the conceptual representations corresponding to words and sentences. Other theories tell us that, well, no, the semantic representations serve to map labels onto their corresponding concepts. So, in other words, the semantics, the meaning is very important because we use that meaning to then create verbal labels onto the concepts that we hold in our mind. So it's a very, very hot area of research right now to try to figure out what's the relationship between the meanings that we have, that we understand in the world, and the language that's used to express those meanings. Pragmatics is the area of language use. How is language used in particular contexts? Um, Language is more than just stringing together letters and sounds. It's 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 used in different ways to convey a lot of different meanings. And pragmatics really looks at how it is that we use language in day-to-day communications to convey meaning. Um, and we look at the way language is used to represent abstract thoughts as well as concrete things, and how we combine different words to produce different types of meanings. Um, for example, here's an example. My teacher butchered my paper. That's a very if you take that literally, it means that somebody came up with a knife and a bone saw, and started like butchering a paper like they would butcher a pig or a cow. um but that's not the meaning there. The meaning is really that, oh, my teacher harshly graded my paper. That's a very that's a tough thing for English as a second language speakers to understand, right? But again, the field of pragmatics is looking at these different ways that we use different words in particular contexts. What are the contexts that we use certain words? So let's go now a little bit to how we process language. We don't know a lot about how the brain processes language specifically. Two of the most famous people that made some initial discoveries about how the brain processes language were Paul Broca and Carl Wernicke. That's not Wernick; it's pronounced Wernicke, I think anyway. Um, and Broca was the first to identify a type of aphasia. Aphasia is basically an inability to produce speech. And in Broca's aphasia, it usually results to damage to the left inferior frontal cortex, and it involves problems with speech production. So you can understand what's being said to you, but you have a lot of trouble producing speech. Some of you may have seen this in relatives that or friends that have had a stroke. A lot of people that have had a stroke will end up with a language deficit. And if it happened to damage this area that Paul Broca identified, which is now known as Broca's area, they're going to have trouble producing speech. Similarly, Wernicke's area is Wernicke also identified an area of the brain in the left posterior temporal lobe, so a little further down in the brain on the cortex. That when it is damaged produces problems with speech comprehension. So, in other words, there's this inability to understand speech. The weird thing is that speech production is intact. So the patients end up producing this sort of word salad. They'll just like they'll talk, they'll say words, but the words don't mean anything relative to each other. They're just kind of putting out this like salad, this meaningless mix of words. Here's a picture of uh, a patient named Tan, his brain. And if you notice the if you look at the brain, right, there's essentially like this like yucky looking hole there on the if you look at the picture on the left hand side, there's this yucky looking hole there on the sort of the left side of the brain. Uh, the brain that you're looking at, we're looking at the side view of the brain. So the as you're looking at this picture, the brain is the person would be looking off to your left, and it would be looking at the I guess at the left side of their head, right? And that hole you see there pretty much exactly where um, Broca's area is, and then you can see the MRI that was made, and you can see that massive like rip that's there on the left side where that entire part of the brain is dead, missing because of the injury. So, language comprehension, an overview of language comprehension looks kind of like this, right? So, the input is some sentence. And so, the sentence we have is the cat chased the rat. The perception is essentially what you see and what you hear. And of course, that breaks, right? Me, for example, I'm very hard of hearing. So I will you to death because a lot of times I can't make out what you said. And the perception depends on clearly hearing or clearly seeing the words. Once you do form a perception of the language that you've encountered, the next thing is to recognize the words that are in the sentence that you read or heard. So we go through and recognize the words that we heard. So the cat chased the rat. We recognize the words, and then at some point we do a syntactic analysis where we put the words together as they were presented to us to determine what the subject of the word of the sentence was, what the verbs are, what each of the nouns was doing to the other noun or to or doing relative to the verb. And then after the syntactic analysis, we extract the meaning. We extract the meaning, and we also apply our pragmatic rules that we've learned to put together this image of what it is that was being conveyed to us. This overview is essentially all of the different steps that we go through to understand language. And one of the reasons we know a lot about this is because each one of these stages can break as a result of, say, a stroke or brain injury. There are actually specific brain injuries where you lose the ability to recognize words, or you lose the ability to form certain semantic meanings. There's all kinds of very strange phenomenon out there that result from different types of brain injuries. So with language perception, there's a lot of issues with language perception. So for example, there's the problem of co-articulation, right? Um, you know, Written language doesn't have this problem. Written language is very clear, but spoken language, does have this issue of things like co-articulation. Sounds overlap with each other. So, for example, as I'm speaking here, the sounds that I'm producing in producing these sentences, they're sort of just running into each other. We're able to understand it because we each understand English, so we're able to break this up. But to somebody who doesn't understand English, the sounds that I'm producing are just like a string of these nasally sounds that are coming out, and there's a lot of overlap between them. There's also the invariance problem. There are different phonemes out there, and there's different ways to produce phonemes. So, for example, if you're a Russian speaker that's speaking English, you're going to sound like a native Russian speaker. I can't do the accent, but you're going to sound like a Russian speaker speaking English. And you're going to be doing your darndest to produce those phonemes, but you're going to be producing them in a different way than a native English speaker would. There's also categorical perception, and that's an issue in language comprehension that's due to the categorization of phonemes. We categorize certain phonemes as having certain meanings, and when we're listening, we might think we heard one phoneme based on the context, but we really heard another phoneme. But it was really another phoneme that was being said to us. Um, and then there's the phoneme restoration effect, where we don't have to hear all of the phonemes. What we do is we listen, and in the context of what we're hearing, we fill in the blank with any phonemes that we may have missed in the utterance of the communication. So, you'll notice that it's a lot harder to understand people in a very loud environment than it is in a quiet environment. And one of the many reasons for that is because we are not getting enough phonemes, and we're filling in the phonemes that we don't hear with possibly incorrect information. Um, One of the ways that we've studied speech is through the use of spectrograms. And this is an example of a spectrogram. And basically, what this is, it's a visual representation of the sound wave patterns that are produced in speech. And this is in your book in Figure 9.4. There are two spectrograms here. The first one is the spectrogram of the sentence, "The stuff he knows is dangerous." The second one on the bottom is the sentence, "The stuff he knows is annoying." Now, notice the first part of each one of those sentences, "the stuff he knows" and "the stuff he knows." Those two things, if you look at the spectrograms for each one of those two, they're virtually identical. In the first spectrogram, the word "stuff" has a little bit more emphasis to it, so it's more emphasized than in the second spectrogram. But the take-home message here is that just relying on the sounds of speech is not enough. You really need to know the context and other things, because the sounds by themselves are going to be almost identical going across from one sentence to another sentence. It's not really until you get into the meaning and understanding of the words that you can start making sense of it. There's this thing called the word superiority effect, where it's easier to recognize and identify words versus random strings of text. So in this experiment here, what was done was essentially what they did was they asked the subject to focus on the little cross that you see in the upper little panels. And then what they did was they had one of three groups. The first group here on the left was presented with a letter or a string of letters, and then followed by a mask that popped up really quick. The On the mask, above and below the mask, there were two letters that appeared, and the subject had to decide which letter it was that he or she saw. So in the first example that you see on the left is I'm focusing on the cross in the middle, and then somewhere on the screen, anywhere on the screen, the letter E quickly flashes up, and then it disappears, and then it's masked. It's masked over with the at symbol, the little and symbol that you see, and above the and symbol is the letter E and the T. And you're supposed to tell me which letter did you see flash very quickly. Well, when people do this with just single letters, they're only correct 60% of the time, which is kind of interesting, I think. But so the letter flashes really, really quick, right? Just a few milliseconds. Um, if I flash the letter along with mixed in with a non-word, a word that doesn't make any sense, it sounds like it might be a real word, but it's not. So that would be the middle example here. Again, I'm focusing on the cross. And then very quickly, the word "clane" is flashed, and then the mask disappears, and then the mask appears to cover the word "clane" after a few milliseconds. And then I have the E and the T appear, and I'm asked, okay, in the position in the mask, what letter did you see? And only about 65% of the people get it right. What's really interesting is that I can make that 65% go all the way up to 80% and better if I use real words, actual real words. And the reason for this is because we use, in our day to day use of language, in our day to day use of reading language, one of the things that we do and we're very good at is filling in the blanks. If we know what a word is, as soon as we get the gist of that word, the meaning of that word, we're able to use it. So in this example, on the right hand side, again, I focus on the cross. A few milliseconds, the word "plane" flashes up. I know a plane is something that as soon as I see the millisecond, in those milliseconds, I see the word "plane." I know, oh, that's plane. I know that. I know what that is. The mask appears, and then the mask appears over one of the area's letters, and you get two choices. Did you see an E or a T here? 80% or better of the people are able to do this because of the fact that they recognized a word as opposed to they're just trying to figure out positions of random letters. So the word superiority effect is all about the fact that words enable us to understand and more quickly process groups of letters in sentences because we have this ability to do that. We have this ability to fill in the blanks. So mental lexicon it represents the collection of representations of words in our long-term memory. We believe that the lexical information, the words in our long-term memory, are stored as networks of representation. So, for example, if you have, we have here the example, the representation for the word tree, and the semantic meanings of tree is also related to oak, maple, pear tree, fruit trees. All of these different meanings are associated with the semantic meaning of tree. Orthographically, tree orthographic again refers to the letters, the way the words look and sound, right? Not the meaning, but the way they look. We also seem to have an orthographic representation, right? So tree rhymes with bee. Tree looks like the word tread. Tree looks like the word trade or train, trait, treat. Beard is kind of related to bee, right? They both kind of like begin with the same sounds. So these types of representations, we believe, form sort of the mental networks that we use to store both the semantic meanings and the orthographic meanings. Um, the the interpreting a word is happens really quickly. It only takes us like 200 milliseconds to recognize a word. Um, the recognition is recognition of word. The lexical recognition is finding the word, right? So first of all, seeing the word appear on the page, right, and finding it and identifying it. And then lexical access is actually reading the word, knowing the definition and how to pronounce it. um Most of the research is suggesting to us that our mental lexicon, this network that we showed on the previous slide, is organized along a lot of different dimensions: semantic, orthographic, many others. And the more frequently a word is used, the more quickly it's recognized. This is one of the reasons why you want to be a well-read person. One of the reasons you want to read as much as you can. Read the classics. Read, uh, blog posts. Read as much as you can about as many different areas as you can, because that'll give you more words that you can recognize, and it'll make reading for academic purposes or for work purposes a lot easier for you. Word context matters a lot. It word context affects the meaning of the word, so I can prime you with certain ideas that will cause you to recognize words related to those ideas a lot quicker than you would have otherwise. Now, here's an example of lexical recognition and priming. So basically, the task here is this. Over on the left-hand side, you can see the stimuli, right? And basically, the stimuli is just this list of words. Some of the words are real words, and some of the words are fake words, right? So you can see tasp, nurse, doctor, fract, slithist, shoes, doctor. And basically, your task is to respond as quickly as possible whether or not each one of those stimuli is a real word or not a real word. Okay, so pretty simple, right? But here's the priming effect. You'll notice that the word doctor appears a couple of times. The first time it appears, it's preceded by the word nurse. Now, nurse and doctor are related, obviously. The second time it appears, it's preceded by the word shoes. So shoes isn't necessarily something we relate to the concept of a doctor. Whenever you're flying through this list and you're quickly telling me whether or not it's a word, you're going to be a lot quicker to tell me that doctor is a word if it was preceded by nurse than if it was preceded by shoes. And the reason you're quicker is because when I hit you with nurse, that primed the lexical network for all of the things related to nurse. And obviously, one of the things that's related to nurse is doctor. So as soon as you saw the word doctor, you were already in that neighborhood. You were already there. So your response time is going to be much quicker than if I had primed you with something not related to doctor. So when we're interpreting sentences, we go through a lot of different steps here, or there's a lot of different concepts related to interpreting sentences. One of those is syntactic parsing. Syntactic parsing is basically building the syntactic structure of a sentence. Putting it together, putting together the noun phrases, the verb phrases, etc. And that affects how the sentence is understood. Go back to the example of enraged cow injures farmers with axe. There's a funny way to interpret that with the cow injuring with an axe, and then there's the actual way where the farmer holding an axe is injured by a cow, right? The deep structure of a sentence is the actual semantic meaning of a particular sentence. Whereas the surface structure is the order of the words presented in the sentence. Um, so for example, the sentence would think about this sentence. Stephanie kissed the baby. and the baby was kissed by Stephanie. Okay. Those are two different sentences with different surface structures, but the deep structure of both of those sentences is identical. The semantic meaning is identical, right? The noun Stephanie, verbed kissed the baby, um, in both of those sentences, but the surface structure is different. When we're interpreting sentences, there have been these two theoretical approaches that have been talked about. One of them is the syntax first approach, where basically what we do is we go through and first break the sentence down into its syntax, the noun phrases, the verb phrases, the prepositional phrases, the objects, all of these things. We break it down, and then from there we move on. The other one is the interactive approach, where we break a sentence down, look at it, break it down again, look at it a little bit more, and go back and forth to see uh, to ultimately identify its meaning. Both of these theoretical approaches are being studied, and we're working our way through figuring out exactly how it is we go about interpreting sentences. So once let's move beyond sentences. Let's go to texts. Full bodies of text and talking discourse. One of the concepts related to the interpretation of text is the concept of anaphoric inference. Using an anaphoric inference refers to the use of a pronoun to refer back to something in another sentence. So, for example, if I give you the text, so the text would be Dr. Ray Lopez was born in Uvalde, Texas. Oh, I'm sorry, was born in San Antonio, Texas, and grew up in Uvalde, Texas. He attended the University of Texas and graduated in 1986. He then obtained his PhD in 1993 and is currently fat and depressed. Now, in that discourse, there you see he. Who does that refer to? Who does that he refer to? Well, it refers to the first object of the first sentence, which would be Dr. Ray Lopez. And we use that inference, that anaphoric inference, to make the connections back to whatever pronouns are referring to. Um, Language comprehension is very, very tightly connected to perceptual representation. So, our ability to understand what's being said is going to be related to what it is that we're representing in our mind. Um, for example, when we're using anaphoric inference, we refer to gender, the he's and the she's, and the accessibility to quickly determine what the correct reference is for a particular pronoun. We end up piecing together sentences, filling in the details to make sense of what we've heard or read. So we do use a lot of inference in when we're breaking down and understanding texts. So speech errors are very interesting. They give us a little bit of insight into what it is that what it is that we're doing, and we make errors across all the whole range of the linguistic units and the linguistic concepts that we've talked about to this point. We make mistakes across all of those. Here's some phoneme related errors, right? Switching phonemes around, right? So the York Library becomes the Lork Yibrary. There's anticipation phonemes, where instead of saying reading list, we say leading list. There's perseveration, beef noodle, beef needle. Addition, blue bug, blue blug. We've all made these types of errors, these types of sound errors before. There's also morpheme errors where we move around stems and prefixes and suffixes. So thinly sliced becomes slicely thinned. My car towed, my toe toed. Explain, rule insertion, rule exertion. Some weeks, some's weeks, gets it, get it's. All those different morpheme types of errors. We make word errors, exchanging words, writing a letter to my mother, writing a mother to my letter, etc., etc. And then we also take a look here at language production, right? Actually producing language. Now, some folks have proposed that language production goes through a series of processes: conceptualization, formulation, and then articulation.